Hello everyone, welcome back to the series. This is episode 8 of building a chat app in C from scratch. In the last episode, we implemented our chat server and a basic client which demonstrates communication. So you guys can see whenever we run our client, it sends a message to our server and it also receives one from our server. We also implemented our socket library as well. Today, we're going to be integrating our client or our socket library into our chat application so we can perform real communication. So if we say send a message like, "How are you?" to a person, they actually get it. We'll also implement broadcasting, which will actually allow us to communicate with other people, into our server. So don't forget to hit the like and subscribe button, and let's dive right in. Alright guys, so let's start integrating our client into our chat application. So currently, guys, if we let's start our server. So if we execute our server, hold on, let me compile the server. So chatsop.c-lws232-server. And then we execute our server. And then we try to build our application. If we send a message, our server will not see what we have sent. But if we execute our client, let's compile our client real quick. So chatsop.c-lws232-client. But if we execute our client, it works. So let's actually integrate our client into our real application. So let's start by modifying our server. Guys, so let's open up our server.c. We'll get rid of this while loop for now. And we will only accept one single client on our server. And we will just have a infinite loop. We'll do a while one. And we'll just have a char buffer of 1024 bytes, and we'll receive a message, and we'll get rid of this chatsop close thing. Let's put it down below here, outside of our loop. And now guys, let's actually integrate our client in here now. So let's open up our app.h, and let's also look on our client.c, right? So we include our chatsop.h header file, right? But instead, in our app.h, we're going to include our chatsop.def.h, which is our socket data type. Inside of our app structure, we'll define a server socket. And so it will be a chatsop t server sock. And then guys, let's open up our app.c. And in our app create function, we'll initialize our server socket. So we'll create the server socket. We'll do a chatsock_create. Oh, we need to ensure that we include our chatsock.h header file. And we'll do a chatsock_create. We'll specify our localhost address 127.0.0.1 and our port is 777. We'll just copy this and open up our upconfig.h header file, and we'll just paste this port definition in here. Now guys, in our up.c, we will just put our port in here, and let's actually ensure that we connect to our server on that IP address. So we'll do a chatsock connect &up server sock. And then once we have done that, guys, oh, this should be server sock, not server socket. Then now guys, we can go into the part where we actually send a message when we press enter on our keyboard. So in here, we'll just do a chatsock_send, and we'll pass in our up server socket, and we'll pass in our up input box.data, and we'll get the length of our data by calling the string length function. So we'll pass in our up input box.data, and then we'll send it to our server that way. Now let's ensure that we close the socket. So we'll do a chatsock close up server sock inside of our up destroy function, so that everything gets closed. So it should be a pointer. So we pass a ampersand there. So now guys, we will recompile our code. So let's recompile our server. Let's execute it. And let's run our build script. Now it will give some linking issues because we forgot to include our socket library. So we'll just add our chatsock.c in here, and also we need to ensure we link to the Windows socket library, so -l ws2_32, and let's do this for Linux as well. So we'll just do a chatsock.c right here. Alright, so now our build scripts are good to go. So let's execute our build.bat. Wait, before we do that, guys, let's go back to our up.c in our create function. And let's say if our chatsock connect server sock right, so connect, let's say it's less than 0, then we'll do a printf on std error failed to connect to the server, and we'll do another else. We'll do a printf do a printf connected to the server successfully. And let's run our build script, guys. Alright, it's building. Alright, so it failed to connect to the server, guys, for some reason. Oh, why is that? Oh, that's because we forgot to initialize our socket library. So we need to call chatsock init. Let's put that inside of our up init function. So we'll just do a chatsock init. And then, guys, we can just close this and recompile our code. So let's wait on that to build real quick. Alright, so now our server said it got a connection. So if we send something like hello, you guys can see it displays on our server. We can send something like how are you today? And you guys can see our server displays that. Let's send I am doing great. And you guys can see that. Now guys, it's time to actually make our server multi-client. So we'll implement broadcasting, right? Because right now, wait, give me a second. Let's say we open up another window of our application, right? And we send a message. Our server did not get that connection, so we need to make our server multi-client support now, right? So let's actually do that. So guys, in our server, let's actually create a chatsock list library, because we're gonna need to store each of our clients that connect to the server, right? So let's focus on that for now. So we'll just do a hash include let's include our so this is our chatsock def.h. Inside of here, let's define a type def struct chatsock list. We'll say chatsock t chatsock underscore list t, and it will have a chatsock t pointer socket list, and we'll have a size t of count. Let's just call it list and count. We'll define, alright, so in our chatsock list.h, we'll just include a chat sock def.h yeah, we'll include that chat sock def.h, and we'll define some prototypes. We'll define a chat sock list init function, which will accept a chat sock list t pointer socket, and a void pointer chat sock list destroy chat sock list t pointer socket. We'll then have let's define a chat sock list underscore add socket chat sock list t pointer socket, and it will just take a chat sock t of a socket, and we'll append it. We'll also have a chat sock list underscore close all function chat sock list t pointer sockets, and let's now copy these prototypes and paste it in our chat sock list.c file. So we'll just include a chat sock list.h header file, alright. So let's ensure that we define these header guards, guys, to prevent multiple definitions of our functions. So we'll do chat sock list h, do a hash endif right there. So now let's implement our init function. So we'll say set our sockets list equal to null. We'll set our sockets count to 0. Let's now create our destroy function. So let's see what it will do. It will essentially call chat sock list close all and pass in our sockets. Then it will set our sockets list to null and our count to 0. So we'll just call our chat sock list init function on our sockets. So our close all will essentially iterate through each of our sockets. So our sockets count I++, and we'll do a chat sock close let's actually define our chat sock list in our chat sock dot h, right? So we'll do a hash include chat sock list dot h, and in our chat sock, let's not do that. In our chat sock list.c, we'll just do a hash include chatsock.h, and then we'll include our chatsock list.h. So then we can just do a chatsock close on our sockets list at index I. And we need to pass that in as a pointer. Alright, so now our add sockets, guys. So our add sockets will essentially do a, so we'll do a hash, no, we'll do a chatsock t pointer new sockets equal to nulls equals to null, and we'll say new sockets dot, yeah, we'll say define another thing as well. We'll have a size t new count. We'll set that equal to our sockets count plus 1. Our new sockets will just be realloc sockets list, and then our new count times the size of a chatsock t. We'll then say if not new socket. So if we failed to allocate memory, then we'll just return. We'll then say if we didn't fail, we'll just add our socket. So we'll just say new sockets at index new count minus 1 is equal to sock. And we'll say our sockets list is equal to our new sockets, and our sockets count is equal to our new count. Alright guys, so now let's start integrating our chatsock list into here. Yeah, let's include our chatsock list in here. So we can just have one include for our server. Right, so now guys, here's what we can do. So right here where we're accepting our clients, we can just have a while loop which accepts a connection. We'll have a chatsock list t up here. Let's just call it client list. Client list. Chatsock t client list. We'll just initialize it to 0. And inside of here we'll accept the connections. We'll then say once we accept the connection, we'll do a chatsock list. What did we? Yeah, here's our add socket function. We'll do a chat sock list underscore add socket. Then we'll pass in our client list, and we'll pass in our csock, which is our client socket. So it will get added to that list. Yeah, so let's test this out now, guys. So I'm gonna just delete all of this thing right here that handles receiving messages and stuff. So I'm just gonna call chat sock list destroy sock client list. So we'll pass in a pointer to our client list. In our chat sock list .c, let's see if we're doing everything correctly. Oh, we need to ensure that we free our memory, guys. So we'll call free, and we'll pass in our sockets list before we initialize everything back to its default values, which is null and 0. Yeah, so we don't have any memory leaks. So now, guys, we can essentially recompile our code. Let's just do to start cmd.exe. So start cmd.exe. And let's just create a little split view right here. So we'll compile our server, guys. So we'll type gcc server.c chatsock.c chatsock underscore list.c dash lws232 dash o server. And we'll execute our server. So now our server is listening, guys. Now, I'm just going to my desktop, then the chat up directory, and now we can compile our window, our chat up window. So execute our build script, build.bat. Alright, so you guys can see the server got a connection. Now let's try to run another instance of our chat application. So I'm just gonna create another split view right here. I'm gonna go into our desktop, chat up, and we'll just execute our main. And you guys can see we have two windows, and we both have a connection to the server. Let's run another instance of our application. So let's do cd desktop / chat up. Then we'll just execute another window. See, so now, guys, our server can accept multiple connections. But what if we want to send a message now and let the server receive the message? For that, we're gonna need to do multi-threading. And then, so here's how it will work, guys. So our server will receive a message from a single client or an instance of our chat application. Then it will broadcast or relay our message to the other connected clients. So let's actually let our server receive a message now from each client. So for that, we're gonna be doing multi-threading, right? So that we can handle multiple clients and all of that. So for now, I'm gonna be using P threads, the POSIX threads. And then later on, we're gonna be using SDL threads. But to keep it simple for now, let's just use P threads for now. So guys, all we need to do to receive a message from each of our clients is essentially create a thread for each of them. So we'll have so to create a thread using P threads, we need to have a P thread T inside of our server, right? So a P thread T and a pointer, just a P thread T, and let's just call it our receive thread. And we'll call our P thread create function, which allows us to create a thread. Oh, yeah, it should just be like this. And then we call our P thread create function. It accepts a pointer to our thread. So P thread will return a ID for our thread. And we'll create our thread using this function. So the attributes, we're gonna set it to null for the default attributes. And we need to create a function, guys, that will allow us to receive our message. So we'll just have a void pointer up here. And let's just call it receive message. And it will accept a void pointer. Let's just call it arg. And it will accept a chat sock T pointer client sock equals to chat sock T pointer arg. So then now, guys, we can just literally do a while loop. So we'll do a infinite loop. So we'll say while one. We'll just do let's define a buffer up here. Char buff 1000. No, let's not do that. Let's just do it like this. Char buff 1024 bytes equals to 0. So we null terminate everything. We'll then do a receive, a chat sock receive. We'll pass in our client socket. We'll pass in our buffer, and it will be 1024 bytes. We can just do size of our buffer, and then we can just say printf received message from client. And then we can say %s new line, and then we pass in our buffer. Oh, so our chat sock receive just accepts a structure, so we can just dereference that pointer. So now let's go back to creating our thread. So we call this P thread create thing. So we set it equal to null, right? We will essentially pass in our function. So we pass our receive message function, and then we need to pass in an argument to our function. So we'll pass in a pointer to our C socket for now. Yeah, this should actually be alright guys, so now that we have done that, we need to ensure that we join our thread. But here's the thing guys, we're not gonna do that as yet. So once we join our thread, it will essentially wait till our thread is finished, but it will block our loop. So we're not gonna do that, but later on we will start doing that. So we're just gonna leave that out for now. So let's just test out our server and see if it can start printing out messages and stuff. So let's go back to our command prompt, and we're gonna recompile our server. And let's execute our server, and then let's also execute our actual chat application. Let's execute another chat application, and let's try to send a message. So it's printing out infinitely for some reason. Probably the socket is this should actually be a pointer. Let's recompile our server one more time. Let's close this. Alright, so now let's execute our server, execute our main program. Yeah, it's printing too much times for some reason. So this is our client socket. We pass it in as a parameter. Oh, but it's on the stack. Oh, okay. Alright, the parameter that we pass in, let's actually pass in the index of our last client instead. So we'll just do a ampersand client list dot list at index client list dot count minus 1 dot fd. Alright, so now let's try to recompile our server. And let's execute our server. Let's execute our main program, and now it stops spamming the receive thing. So if we send hello, alright, it received it. Now let's execute another window. Alright, it got a connection, nice. Let's execute another one, yes, it got a connection. So now guys, you can see we have 3 windows here. right? Let's resize these windows so we can put them beside one another. Yeah, let's do this. All right, so this is one of them, right? So let's send a message in one of them. Let's send how are you? And let's see if our server actually receives it. So if we press enter, all right, our server receives that message. If we go over here and we resize this window and let's send a message. Let's send like, I am doing great. And I press enter, you guys can see it appears in our console. Now guys, how do we actually get our message over to the other client? That's where broadcasting comes in, right? So our server receives the message from a single client, it then distributes it or relays it, or you can say broadcast it to the other connected client so that they get the message. Guys, look at this, guys. Now it's multi-client, so we can literally send messages from any one of these, right? We can do anything, right? So, bro. Yeah, so we have these chat windows, right? Our server gets everything, right? So now, guys, we need to implement broadcasting. So let's see how we will do that. Oh, by the way, guys, let's actually create a new folder. Let's just call it our server, chat server, and we'll just move this server.c into our chat server. Let me do it from the terminal. So I'll just write move server.c into chat server. And we'll create a build script. Now guys, you see this client that we have? We don't even need it anymore, right? Because we have integrated our client into our chat application. So this means we can just delete our client.c. Can also delete our client.exe as well. All right. So now, let's also delete our server.exe as well. So now, let's actually create a build script for our server. So let's just call it build.but, and we'll just do a @echo off. We'll then say chat. We'll then say echo building chat server ... We'll then do a gcc server.c ... chatsock.c dot slash chatsock.chatsocklist.c dash lws232 dash o chat server. We'll then do a run in chat server dot. We'll then say chat server. So now that we have done that, guys, let's actually rename this server.c to chat server.c. And let's change this server.c to chat server.c. Alright, so let's test out our script to ensure everything is working fine. Well, it won't work fine because we need to modify our header files, alright. So we need to do cd chat server, then we just execute our build.but, and we'll get a compilation error because we need to do a dot slash to include from the previous directory. And then now we can execute our build.but. Alright, so our server has been executed now. Alright, so now let's execute our application. Let's execute another one. So now we have two windows. Right, can send a message in one of them. Let's say this is window 1, right? This is window 1. We can say this is window 2. And you guys can see our server is receiving these messages in our console right here. Alright, so let's know that it's working. Now guys, we don't have to type out this long command anymore because we simplified it into a simple build script that just builds our server for us. So now we can just easily build our server. So let's actually start implementing broadcasting into our server. Alright, so let's focus on our chat server. So we'll essentially need to create another thread, guys, so once we receive a message, we need to create a thread to broadcast it to the other clients. Right, so this means we'll need to also create another thing. Let us create a new file. Let's call it chatserver.h. We'll do a hash if not defined underscore chat server underscore h hash define chat server h hash and if. We'll do a let's see. Yeah, we'll do a hash include say chat.def .h, so it will be // chat.def.h. We'll then say, so we'll need to have a structure, guys, because in order to distribute or broadcast the message to other clients, we will need to iterate through this list. And then p threads, we're only allowed to pass in a single argument to our function. So we'll essentially need to create a structure that we will use to broadcast. So let's just do a type def struct. Let's just call it broadcast args. We'll then say broadcast args underscore t, broadcast underscore args t. And let's see, the two things we'll need are the clients list and the current socket. So we'll have a chat.t client, and we'll have a chat.sock we'll have a chat.sock.t client list. A chat.sock list t pointer client list. And that should be it, guys. So now, in our chat server.c, we can just include, let's actually copy these definition, these includes right here. And in our chat server, can just paste this in. And then we can just do a hash include chat server.h. Right, so now guys, let's create a void pointer send message now. Well, let's just call it broadcast message. And it will accept a void pointer arg. So essentially, we'll get the broadcast args t pointer. Let's just call it broadcast args equals to broadcast args underscore t pointer arg. And then we can just say while one let's see. For now, guys, we're not gonna do this as yet. So we're just gonna say send. We're just gonna iterate through our clients list. So we're gonna say for size t I is equal to 0, I is less than or broadcast args client list dot client list count I plus plus. Then we will see if or wait, let's actually put this into a pointer for itself. So client, so it looks more clean. So client list equals to broadcast args client list. We'll then say I is less than our client list count. We'll say if our client list this shouldn't be client list, guys. It should be chatsock list t pointer. Client list. Then we'll say client list at index I is not equal to our broadcast args client. So if our socket is not equal to, or our socket file descriptor is not equal to that particular client, wait, let's say if it is equal, then we'll just skip it, right? Because we don't want to send or broadcast the message back to the sender. We just want to broadcast it to all the other clients. Alright, so now we can just say client underscore list at index I is equal to broadcast args client. Then we just continue, so we skip that client. Client list index I should be, it should be .fd because we want to check the file descriptor, guys. Yeah, and then we can just do our client.fd. So if our file descriptor, if our client list at index I file descriptor is equal to our sender file descriptor, then we'll skip that. Otherwise, we will just send our message. There's one more argument we need to pass in, guys, which is our actual message that we receive. Right, so we'll do a char pointer. Let's say message. Yeah, char pointer MSG, right, for the message that we want to send. So then we can just do a chatsock underscore send, and then we can just pass in our broadcast args client, and then we pass in our broadcast args MSG, and we just get the length of that broadcast args message. Yeah, and that should be it, guys. So now, whenever we receive a message into our buffer, guys, we can essentially just create a new thread from within our receive message function. So we'll do a pthread t. Let's call it broadcast thread equals to we need to do it here, so we need to say pthread create % broadcast thread null. Then we pass in our broadcast message function, Let's also define up here our broadcast args underscore t structure up here. So let's just call it broadcast args and our client will be equal to our client socket and our client list. Wait, so we'll need our client list, guys. So we'll need to define something else. So let's do a type def struct receive args, and we'll accept a chatsoc t client, and then we'll accept a chatsoc list t pointer for client list. Then we'll say sharp pointer message wait, let's just make this be receive args t right here, because it's similar to the broadcast args function. Let's rename this to communication args. And let's create another type def. Let's call it communication args underscore t. Right? So now we instead of calling it this, we can just write underscore args underscore t broadcast args args underscore t pointer broadcast args, and then it is equal to our let's do args underscore t pointer, and then we can just say our chatsoc t client soc is equal to args client communication args t. So args client. All right, we can just cast this. We can just cast this to a communication args t pointer. Right. So now we can just pass in our client socket, and then we can just pass in our args thing right here. Alright, so now guys, let's actually modify our receive message creation thing. So we can define a args communication args type args up here. Can initialize everything to null for no. And then right here can just say args.client is equal to our C sock, then args.client list is equal to our, let's see, is equal to our a pointer to our client list. Then we can say args.message is equal to we don't have to really do anything about that. Because receive doesn't really need that. Okay. Let's actually define another communication args after this. So we'll have a communication args right here. Let's call it broadcast args. Let's call this receive args instead. Receive args. Receive args, broadcast args. Alright. Our broadcast args will just take a copy of our receive args. And then can just do this receive args right here, client. So then now guys, in our broadcast thing, can just pass in a pointer to our broadcast args. And then that's literally all we need to do, right? Wait, that's not it. So it needs a pointer to our message, right? So we need to ensure that we do a broadcast args. Need to ensure that we do a broadcast args dot message is equal to our buffer, and then let's do a pthread join right here just to wait. So a pthread join on our broadcast thread, and then we just set our result or our return value equal to null because we don't want any return value. And let's just do some basic logging. So we can do printf creating and broadcasting message to clients. And all right. So now let's rename this com.args thing to just receive args. And then we can just rename this to receive args dot client equals to csock client list. All right. And then guys, we need to replace this parameter now with our receive underscore args. And this looks good. So now guys, let's actually make our up actually receive a message. Right? So let's just keep it simple for now. So our up will just do a chatsock underscore receive chatsock let's just have a char buff server message 1024 bytes equal to 0 for now. And we'll receive into our from our up server sock into our server message 1024 bytes. Now guys, this will block the main thread. So we'll need to also create another thread, right, for our client. So let's include pthread.h in our app.c. And also, let's copy this receive thing. And let's create a simple receive function. So we'll do a void up underscore receive message void. Let's make it a void pointer. And we'll say we'll just do this for now. So it will accept a void pointer arg, and then we'll pass in, we'll need to get our argument. So therefore we'll just get our, pass in our up t pointer. And then let's see, our up equals to up underscore t pointer arg, and then we'll just return our server message. Now let's let this be heap allocated, guys, because once that is returned, if it's a stack variable, it will become invalid memory. So we need to heap allocate it so it remains valid. Right, so this will be 1024 bytes, server message. Let's do a calloc so that our message or whatever buffer we receive is null terminated. Then now guys, let's actually test it out. So inside of our uprun loop, we can just do a pthread underscore t. Let's call it receive thread equal, and then we'll do a semicolon right here. We'll then create our thread. So we'll do a pthread create, passing a pointer to our receive thread. We'll then set the attributes to null for the default attributes, and we'll then pass in a pointer to our up receive message function, which will then accept a pointer to our up. So just pass in our up there, and then let's actually define a global variable up here for now. So int, let's make it a int received message. And we'll set it equal to, let's make it a bool received message. We'll set it equal to false. We'll then say in our up receive function, after we have received the message, we'll then set our up we'll then set our received message variable equal to true. And then here's what we'll do guys. So let's also have another flag. We'll have another variable. Let's call it receive thread started, and we'll set it equal to false. We'll then say right here, if not receive, what's the variable again? Your receive thread started. So if not recv thread started, then we will let's actually define the thread under pthread t all the way up here, because we'll need to save it so that we can get the message that we receive. So we'll have a pthread create right here. Alright, so now whenever we start the thread, we'll ensure that we'll say if receive thread is started and received message is equal to true. So we can just say received message. Then we'll do a pthread join receive thread ampersand message. Let's create a char pointer message right here, and we'll set it equal to null. At the end, we'll then say, so after we get our message that we received, we will append it to our message list. So we'll say up message list, up input box font, up font size, and then we'll pass in our message. Then we'll pass in, let's make, instead of using the green message color, we'll make our color a different color. Let's make it something like red this time. So our value will set it equal to 0xff, which is 255, green 0, green, red, blue 0, alpha fully bright. So, and our padding, we'll make it be the default. So 10, 10, 10, 10, space x10, message canvas color, we'll make it be the same message canvas color. And then guys, we just free our message. And right here, we can just say receive thread started equals to false, received message equals to false. Then we can say up here, receive thread started equal to true. So then now guys, let's actually test out our application. Alright, so let's try to compile our server by running our build script. Alright, it's listening. Now let's try to compile our actual application. So we have an error. Oh, it's a char pointer message, but it accepts a void pointer pointer. That's just a warning. Yeah, we don't even have to really care about that, but we can just cast our message to a void pointer pointer, and then we can just rerun our build.but. Alright, let's run another instance of our application as well. Let's go into our desktop and our chat up, and then let's execute our main. Alright, so now we have two windows. Let's test it out to see if broadcasting is working fine. So if I send hello, the server actually broadcasted it, but it sent it to the wrong user for some reason. If I send F, the server sends it back to me, but it didn't forward it to. So let's see what's going on, guys. Let's see what's going on. So if I go in my up.c, wait, in my chat server.c actually, I check if the client list.fd is equal to the broadcast args client.fd. Then we skip that. Otherwise, oh, I'm broadcasting it to the wrong file descriptor. That's why. It should be the client list.indexi.fd. So now, guys, if we test this out again, so let's open up our command prompt window again. Let's close all of these windows and let's recompile our server. Let's recompile our code. So we run our build script for our server. We have an error. Oh, it shouldn't be our FD. It should be just our client list.indexi. Right? Alright, so now let's open back our command prompt. Can rerun our build script. Alright, now we can execute our application, execute another instance again. So main.exe. Alright, so now we have these two windows. So let's see if we can send message to each one of them. So if we send hello right here. Wow, let's go guys. Nice. It works. How are you? Wow, it works, guys. Alright, let's reply to him, guys. Let's say I am doing great. Wow, guys, this is so cool. This is so cool. Alright, so why is our application crashing for some reason? It's not responding. Let's see what's going on. But it works. It works. So we implemented broadcasting in our server, guys. So that's really good. That is really good. So let's try to figure out why our application was crashing for some reason. So this is our buffer. It isn't with our server, but instead it is with our client. So we set received message to true, and we return our server message. Wait, let's test this out one more time. So if we execute our build.bat script, it's building the server. Then we execute our main.exe. Let's recompile our probe code. So we run our build script for our actual application. And we rerun the other build script. Alright, let's wait on it to compile. Alright, this one is compiling now. It's compiling. It's taking a while to compile. Yeah, let me close this server. Alright, let me re-execute the server. So if I execute the main application, execute the other one, let's open up 3 instances of our application. So to shut up, sorry, it should be cd into desktop / shut up. And let's run our main.exe. Alright. So now we have these 3 windows that we can communicate with. Let me just resize them so that they fit onto the screen. So let's actually send a message, guys, and let's see if everything is working fine. So if we say, let's say, this is window 1, every one of them receives that message. Nice. We can say now, this is window 2. Every one of them receive. Okay, so it's not being null terminated for some reason. We can say this is window 3. Right. So it's actually receiving the messages, guys. Alright, so if I close that, okay, that's where it crashes actually. Yeah, and that's because we haven't really handled those stuff really well as yet. But anyways, guys, this will be it for today's video. In the next video or episode, we will be handling disconnections so that our server closes connections gracefully. And we'll continue working on making the chat up more robust. So thank you guys for watching. Hit the like and subscribe button. And I'll see you all in the next video.